and welcome back. This is the first video of a new series, Data Structure. This video is going to be about arrays. What are arrays? An array is a collection of data stored at contiguous memory locations. When we look at an array, for example, we're taking this array with elements A, B, C, D and so on. When we look at this array, you can see the memory allocated to this array is given by 100, 101, 102, 103. So you can see there are no gaps in between the memory addresses when we are storing an array. So if we talk about an array, the elements are stored together in the memory. That is what contiguous means. So you can see there's an index that is corresponded to every element in the array. Now you can reference that element using this index, and it's a unique index for every single element. So if we have an array of n elements, then our index will go from 0 to n minus 1. So we will not have any element at the index n, which is the size of our array. This is how we represent an array. The first ARR is the name of the array. The 0 in the square brackets is the index that you're referring to. And if we look at the whole thing, the ARR and 0 in the square brackets, then it's referring to the first element in our array. So what if we try to access an element which is at the index n, which is the size of our array? We will get an error of index out of bound because that index is not present in our array, because the maximum index that can be there in our array is n minus 1. So now there are two types of arrays, static and dynamic. So static arrays are arrays which have fixed length. You cannot change the length of an array if it's a static array. Dynamic arrays, on the other hand, have variable length. There are two important points about static and dynamic arrays. So the first point is, for a static array, the memory is allocated at compile time, and for dynamic arrays, the memory is allocated at the runtime. The second point is that the memory is allocated on the stack in case of static arrays and on the heap in case of dynamic arrays. Now stack and heaps are a totally different data structure that we'll be covering in our future videos, but this is a point that you should remember. So complexity. Now we will be talking about complexity of both static and dynamic arrays. Remember that the size of the static array cannot be changed, so we'll see why that's important. So if you want to access the elements of a static or dynamic array, the complexity will be constant. But if you want to look for an element inside the array, then the complexity will increase to linear. Now why do we see not applicable for insertion, appending and deletion in static arrays? This is because you cannot change the length of a static array. So we cannot insert an element when the array is already full. So we will not be talking about the complexity of insertion, appending and deletion for static arrays, but for dynamic arrays, it's given here. So if you want to insert an element in a dynamic array, you will probably have to increase the length of the dynamic array, so the complexity becomes linear. But if you want to append, then it remains constant. And again, if you want to delete, which is kind of similar to insertion, then the complexity will be back to linear. Static arrays. There are two types of static arrays. One is single dimension and the other is multi-dimension. This is how we declare a single dimension array. First, the data type. It is necessary because we want to know what type of elements are there in our array. So if, for example, we are making an array of integer type, so instead of data types, it will be int, then the square brackets and array. Now remember, this syntax is in Java. First, if you are talking about integer arrays, then instead of data types, it will be int, square brackets, and the name of your array, whatever name you want to give. Then again in this one, int, square brackets, int space square brackets, and the name of your array, int space name of your array, square brackets. But this is the most conventional way of declaring an array. Now if you want to declare and initialize in Java, so first you type the data type of their array. This is the variable name. You can type ARR also. The square brackets equal to, now new. This keyword creates a new object. So we are essentially creating a new object of this. Now this will become an integer array of size 3 and we will initialize the values. So the first element will be 10, the second will be 20 and the third will be 70. So that is about single dimension arrays. Now multi-dimension arrays. So we're talking about a 2D array for now, but you can make as many dimensions as you want. So it's kind of similar to single dimension arrays. So the data type, the square brackets. Now this square brackets, if there are 2 pair of square brackets, then it's a 2D array. If there are 3 pair of square brackets, then it's a 3D array. As per this example, we have 3 rows and 2 columns. So while declaring, we'll be typing int, the name of our array, the 2 square brackets for 2 dimension equals to new, so that we can create a new object, int 3 and 2. Now while initializing it, remember that the index starts from 0. So the first element will have index 0, 0, initialize at 10. So now remember that because this number, the number in the first square brackets is 3, so all the numbers in the first square bracket should be less than 3, not even equal to 3. So we have 0, we have 1, and we have 2, not 3. Right? And in the second square bracket we have 2, so all the numbers will be less than 2, which is 0 and 1. 0, 1, 0, 1, 0, 1. So instead of doing this whole process, first declaring and then initializing, you can do this both in one single line, which is this, using the parentheses. Now you write the data type, the name of your array, the square brackets corresponding to whatever dimension you want it to be, and these are all the elements. Now how to implement a dynamic array? So what we do is we make a static array. For example, take a static array of length 4. Okay, insert the elements at the first position, second position, third position, and fourth position. Now when you have filled all the positions and you want to add one more element, then you will make a new array, double the size of the first array. So the first array was of size 4. Now you have an array of size 8. And then you add your fifth element, then 6th, 7th, 8th. Then you create another array of double the size of the second one. So that will be 16. And then you can add all the required elements. If you're not familiar with Java, just try to understand what the code is actually doing. So we start by variables, length and capacity. So length is the length of the array, what the user thinks it is, and capacity is what the actual length of the array is. This method just creates an array of size 16. Looking at the second function, this creates an array of capacity, whatever you enter. For example, you input 8. So this function will create an array of size 8. As you can see, it's creating an object of that capacity that we entered. Now the size function just returns the length of the array. So it's nothing much. Then this is empty function. Now is empty functions tells you if the array is empty or not. So if the size of the array is 0, it will return true. Otherwise it will return false. Because its return type is boolean, so only true and false will be returned. Now this clear method clears everything that is there in that array and makes its length to 0. Whatever the capacity was, the length will be changed to 0. The name of this function is add, and it inputs an element. So it can be anything. It can be a piece of data. It can be a name, a phone number, or anything of that sort. So if length plus 1 is greater than or equal to capacity, then we go to this part of the loop. If the capacity was 0, we'll increase the capacity to 1 in order to add that element. If there was some specific capacity, for example, we took 8 in the beginning. So if we had that capacity, then it will be doubled, which will be 16. Then a new array will be created of that particular capacity. And then this new array will have all the elements of the previous array with the new. So this new array will have all the elements of the previous array. And then we'll add our new element to this array as well, to length plus 1 position. I think that's clear. I will make these changes. This is wrong. This part should be this. So I'll make that changes later on. Now we come at our next function, which is remove at. So we take an index at which we want to remove an element. If that index is greater than the length, and if that index is less than 0, then we'll throw this exception, because we cannot remove elements at a negative index or an index out of the array. Now we'll create another variable called data, and we'll store whatever data was there at that index. Okay, so array and whatever the data at that index. Then we create a new array, as you can see, of length less than that of our original array. Now this is a little complex. We have two variables I and j. I is used to traverse the first array that we had, and j is used to traverse the second array, the new array that we created. Okay, so if the index I in the first element is equal to the index we want to remove, then we'll go back to the previous element. Otherwise, we'll just keep storing the value of the elements in the first array to the elements in our new array. Now with this method, we're going to check if that element is removed or not. So remove, so we take in the object. Okay, so we'll traverse the array, and again I've made a mistake here. There should be obj here instead of bj. There should be obj here. So we traverse the array, our original array, and so when we find that element that we want to remove, we just call this function that we made up here and we return true, otherwise we return false. Now this method just returns the index of whatever element you want. So you put in the name of the element, you put in the element, and it looks for that element and returns that index, or otherwise it returns -1. That means that element is not present. Now this function checks if the index of method returned -1, so it will return true or false if the element is there or not. This method we use to iterate through the array. So we make a variable index which is initialized to 0. Then we call a function which is hasNext, which just checks if we have a next element. And the newT method just returns the elements of the array. So it just runs and returns every element of the array. So this method just makes a string representation of our array, and this you can try on your own. If you feel like you're stuck, just use this code. So yeah.